Good afternoon, geometry students. I hope you're having a great day. We are moving on to our second lesson in chapter 4. And as was the case with section 4.1, you're going to be getting 5 points just for copying down the exercises that I do on the board in this video to show that you have introduced yourself to the concept that we're talking about today. So last lesson was about something called translations, which was basically sliding a figure left or right, up or down. Today's lesson is going to be about something called reflections. So I would like you to write 4.2 at the top of your paper and then the word reflections. So you guys are familiar with reflections in real life, and we will be looking at magazine examples of this topic during our Zoom session when we discuss reflections. But from a mathematical standpoint, probably the simplest way of putting a reflection is that we are flipping a figure. We are flipping it over a line. So what I'm going to do is give you 3 examples of reflections mathematically speaking. And then what we're also going to do is look about that, how that can be illustrated in the real world by looking at some pictures of the life around us. So we're going to do example 1 first. And if you have graph paper, it would probably make this a little bit easier to do, but it is by no means necessary. So we are going to first graph what we call our pre-image. Now, if you looked at the notes last time, you know that pre-image means your starting point. It is what your shape or your figure looks like before you do your transformation. So our pre-image points are A is at 0, 2. So we're going to go up 2. Put a dot, label it A, and we can call that, if we would like, 0, 2. For point B is at 1, negative 3. So you want to go 1 to the right, and then 3 down, put a B, and label it 1, negative 3. And then C is at 2, 4. So we're going to go 2 to the right and 4 up, and put a C there. C is at 2, 4. Now I'm going to connect all 3 of these points to form a triangle. Now the directions in this example say graph ABC and its image after a reflection in the given line. This example here, we are going to illustrate reflecting over the x-axis. So let's write that down. Reflecting over the x-axis. So many of you are familiar with the concept of a reflection. Let's talk about what that would look like in the context of a triangle in the coordinate plane. If I want to flip something over the x-axis, of course I'm talking about this line right here, I need every image point to be exactly the same distance away from that line of reflection as the pre-image point. So let's do a specific example. If I start out at A, I count that it is 2 spots away from the x-axis. So to draw my reflection, I want to go 2 spots the opposite direction and put another dot there. I'm going to label that A prime. So what I'm doing is I'm taking point A and I'm flipping it over the x-axis so it's a mirror image. If you were to hold up a mirror here, then I'm going to have the triangle be flipped over that. Now let's try the same thing with B. If we start at B, which is at 1, negative 3, we can see that we have to go up 1, 2, 3 spots. So I would need to go 3 more the other direction. 1, 2, 3, and put another dot. That is going to be B prime. I'm going to erase these little bubbles here because it kind of makes the final picture harder to see. But I do like to kind of use the bubbles when I count to make sure that I'm counting correctly. Now let's look at C. C is 4 spots away from the x-axis, so I can count down 1, 2, 3, 4. It's at 2, 4. So I would need to go 4 below the x-axis to write C prime. And my B is kind of in the way here, so I might move it up just a little bit. So C is going to go down also 4. 1, 2, 3, 4. So it's going to be at 2, negative 4. C prime is at 2, comma, negative 4. I'm going to erase the bubbles so that you can see the picture a little bit easier. And then I'm going to connect A prime, B prime, and C prime. And I think I'll put C prime in pink. Let me go ahead and label A prime. A prime was at 0, negative 2. B prime was at 1, and then positive 3. And if I connect the dots here, you can see that I have exactly the same size triangle, but it has just been flipped over the x-axis. So we're simply counting how far a point is away from the x-axis. And remember, when we talk about distance, we learned this in the last chapter, we always mean the shortest distance, which means along a line that is perpendicular to that line of reflection. So you're going straight up. All right, let's go ahead and look at example number 2. And we're only doing 3 examples for these notes, and then you guys will be done. So example number 2. We now want to reflect something over the y-axis. So let's write that down. Reflect over y-axis. Let's go ahead and draw our x and y-axis. This is our x-axis here. This is our y-axis there. And I'm going to give you the 3 points. A is at negative 2, negative 4. So I'm going to put a dot there with just a regular A. Remember, the pre-image or starting point is a regular capital letter. The image or ending point has a prime mark on it. It's super important that you include that. Notice on my image here, A prime, B prime, and C prime show my ending points. And we're going to do the same thing in this example. So A is at negative 2, negative 4. And then B is at 6, 2. 1, 2, 3, 4, 5, 6, and then 2 up. B is at 6, 2. And then C is at 3, negative 5. So I'm going to go for C, 3 to the left and 5 down. And I'm moving my A over to make a little bit more room. There we go. So I've got, oh, you know what? C was at positive 3, so that's fine. Let's go 3 to the right and 5 down. That'll look a lot better. Good. That helps. Okay, so I've got A, B, C, and I'm going to connect the 3 points. So A was at negative 2, negative 4. B was at positive 6, positive 2, and C is at positive 3, negative 5. Now, if I want to reflect over the y-axis, that means I am reflecting over this vertical line right here, the vertical line. So I'm going to use exactly the same process, but the line that I'm counting the distance to is now the y-axis. So let's go ahead and take a look at A. A is at negative 2. So it means that I am 2 spots from the y-axis. So I don't want to go up or down. I'm just going to go 2 spots to the right of the y-axis, put a dot, and write A prime. A prime would be at positive 2, negative 4. Now, there is an algebraic way of doing this, and I didn't mention this with the x-axis, but I think maybe we have enough practice that I can. If you look when you're reflecting over the x-axis, notice that C is at 2, 4, and C prime is at 2, negative 4. The x's don't change when you reflect over the x-axis, and the y's just change signs. So 4 becomes negative 4s. Now, the opposite happens here. When I'm reflecting over the y-axis, I go from negative 2, negative 4 to positive 2, negative 4. Notice that my y values are now the same, but my x values are the opposite of what they used to be. So if that makes more sense to you to think of it more in the number sense instead of counting, again, it depends on your learning style. If you're visual, you may want to count it out. If you're more of an analyzer and you like to know the rule in your head, you might just want to think about that rule I just mentioned. So for example, if B is at 6, 2, if you're visual, you might want to count 6. 1, 2, 3, 4, 5, 6 to the y-axis, and then 6 more. 1, 2, 3, 4, 5, 6 to get to B prime. If you're not so much of a visual learner, what you can do is say, oh, I'm noticing that rule she just mentioned. Because I'm flipping over the y-axis, what's going to happen is my y is going to stay the same. So y is still going to be at 2, and my x, instead of being positive 6, is going to be negative 6. So that would be a completely legitimate way of doing that. Let's try doing C that way. With C, I know my y is going to stay negative 5, but my x is going to change signs and be negative. So C prime, or the image of C, would be at negative 3, comma, negative 5. Again, I can connect my points when I'm done, and if I've done this correctly, the size of my image should be exactly the same size as my pre-image. Remember that you can, if you need to, pause this video as many times as necessary and repeat as much as necessary so that you can be comfortable with the material. Now, we have one more example and then we will be done with this lesson. So let's do example number 3. This one's going to be a little bit harder, but this is the kind of thing that you would be expected to know in advanced algebra next year. So instead of reflecting over the x-axis or the y-axis, I want to reflect over the line, and let's write this down, reflect. And you know what, we typically when we're speaking say reflect over a line. In the math textbooks and instructions that you might see in a testing environment, it often says reflect in the line. Both of those things do mean the same thing. So I can say reflect over a line, I can say reflect in a line, and they're both really equivalent. I like to say over because I think it's a little bit easier to understand. So we're going to reflect over the line y equals negative 2. Now that's a little bit more of a stretch for some of us to visualize. So let's go ahead and draw a picture of it. The first thing that would be helpful would be to draw the line y equals negative 2. The way I like to describe that line, if you wanted to do a little T-chart, is it's the line where y is always equal to negative 2. So no matter what x is, 1, 2, or 3, it doesn't matter. Y is always negative 2. So let's see what that would look like if I wanted to graph this line. I could go 1 over and 2 down. I could go 2 over and 2 down, 3 over and 3 down. Do you see how the line y equals negative 2 is actually a horizontal line where y is always negative 2 every spot on that line? Now that does kind of confuse some students because they think, wait a minute, the y-axis is vertical. And so they think that the line y equals negative 2 should be vertical as well. But in fact, when we say y equals 2, we're talking about a horizontal line. Okay, this is our last example. Let's graph our pre-image. The pre-image is a at 4, negative 1. So I want to go 4 over and 1 down. And I'm going to label this A. Point A at 4, comma, negative 1. B is at 3, 8. So 3 over and 1, 2, 3, 4, 5, 6, 7, 8 up. And my spacing here is not perfect, but that's fine. So B is at 3, 8. And I'm going to erase some of this example so it's not so much in our way. I don't want it to distract you at all. So make sure you've got those 2 points labeled, A and B. A at 4, negative 1, and B at 3, 8. And then C is at negative 1, positive 1. So right here, C at negative 1, positive 1. I'm going to connect our 3 dots to form a triangle. And then we're going to talk about how we would graph the image of that triangle. So here's our triangle. our pre-image, and we want to know how do we graph its image. Now I'm wondering if you can stop for a minute and think yourself. If we're trying to flip this shape over this blue line here, how do you think we would do it? Anyone have an idea how we would flip point A? A is currently at 4, -1. You can see that it's one spot away from the line y equals -2. So how many spots do you think I need to go on the other side of that blue line? Hopefully you said just one spot. If I count down one spot from A to the blue line, then I just want to go one more to get to A prime. So A prime is going to be at 4, -3. Notice that the X value does not change, but we are subtracting 2 from the Y value. Okay, let's go ahead and look at point B. Actually, let's do C because that's a little bit easier. Let's see how far C is from the blue line. C is currently 1 unit above the x-axis, so that means it's 1, 2, 3 units above that blue line. If C is 3 units above the blue line, how far do you think I need to go on the other side of the blue line? Hopefully you said 3 spots. So we would go 1, 2, 3, put a dot, write C prime. C prime is at -1, and then we've gone down 1, 2, 3, 4, 5. -1, -5. Excellent. We were 3 spots above the blue line. Now we are 3 spots below the blue line. All right, we have one more point to graph, and then we'll be done with our notes here. We need to find B prime. B is currently at +3, +8. Now, don't rush on this one. How far is B above the blue line? And remember, in geometry and math, when we say distance, we mean the shortest distance. So how far is it from B to the blue line? This goes back to what we learned in chapter 3. If you said 8, it might have been because you rushed, because 8 would be how far we are to the x-axis. But since the line y equals -2 is 2 more below the x-axis, we are actually 10 spots away. 8 spots to here and then 2 more. So we would actually need to go all the way down 10 more to get to B prime. So if we start out at -2, we would end up at -10. So I've got to make my picture a little bit bigger here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I would need to go down to 3, -10 to get my B prime. All right, let's go ahead and connect our dots. If we did this correctly, we should have the same size triangle, but it should be visually flipped over that blue line. So what you're going to be doing for your scrapbook project is finding an example of a reflection in nature. This is more a reflection in math, and they're very, very similar. So we'll be talking about that during our Zoom session. Thanks so much for listening, and don't forget to upload your notes. Thanks.